Hi, welcome to the lecture on chapter 6, Encryption Fundamentals. Now, you were exposed to encryption in Security 110. So some of this may be repeat, but some of it I think will hopefully take it a little bit deeper. So let's go through it. We're going to try to explain some of the basic concepts. Look at the history of encryption and some of the modern methods. Then look at decryption, pretty much how people try to break into some security. So just make sure that the basic level of understanding encryption provided in this chapter, no matter how many firewalls, security treatments you put in, if your traffic, your data is not encrypted, it's vulnerable. So you just got to keep that in mind. So you're going to put a lot of other things into place. You can put a firewall together. You can make sure you've got all the latest and greatest software. But if you're trying to protect your data, you got to encrypt it. So what was encryption? Well, encryption is basically used for military communication. Usually in written communication initially, but it evolved telephone, telegraph, radio, internet, computer communications. And of course, those methods have become more complicated as time goes on. Now, some of the early methods were single alphabet substitution. The Caesar cipher replaced one letter of the alphabet for another, just by shifting things over 2, 3, 4, 5 characters. The ROT13 is, hey, I want to move 13 characters in the alphabet. Or the @bash cipher, do things backwards. So do the alphabet backwards. So you got multi-alphabet cipher doing multiple substitutions. I can split the message into different tracks and do that. That's what that rail one's. And then you've got several others that the textbook goes into. Probably one you've seen in movies or back in World War II, the Enigma machine. So some definitely very early methods. Now, basically, we're going to go back and probably the only time you did a lot of binary operations, probably your networking class. But you basically got 3 different types of operations. You got AND, where you got a 1 and a 1, it's a 1. Or you got an OR, that either one of 2 bits that you're comparing have to be a 1 to be true, or the XOR, which says if a position is a 1 and the other one is not a 1. So I got a 1 and a 0 would be equal to a 1. XOR is very good from the standpoint that it is highly used in security because it can be, you can flip back and forth between encryption and decryption to get the same message. Now, there are several good informations. I posted several articles, videos in Moodle, but the author has a couple of courses and research papers, whether it's Coursera or Udacity, a couple of good classes, and then Cipher Research Labs has a history if you're looking for gather some more background into the topic. Now, some of the modern encryption method, and we're going to go through each one of these: symmetric encryption, key stretching, PRNG, public key encryption, digital signatures. We're going to go through all of these briefly so you at least have some exposure to them. Now, symmetric encryption. Now, there's several different types of this. One method is DES. And basically it uses a symmetric key system. The data is divided. It's transposed. The data is sent through various different steps and scrambled. So it goes through several processes. The textbook goes into an example of this in great detail. it gets pretty complicated. I even published a link to the technical write-up on this, so if those of you that like to test out your math a little bit, take a look at it. Blowfish is a symmetric block cipher invented back in '93. The one that's used probably the most today is the Advanced Encryption Standard. It uses a Ringdahl algorithm. It's a block cipher, but it has 3 different key sizes, 128, 192, 256. Of course, the more bits, the more secure it is. Now, there's another one out there called IDEA, International Data Encryption Algorithm. It uses subkeys, so it kind of splits keys and then pads them out to do that. And then a couple others that were back when we were trying to find a better method, when we chose AES as the standard, several of the IDEA, Serpent, and Twofish methods were identified as potential candidates. Now, pseudo PRNG basically stands for pseudo random number generator. Basically tries to get you press the button and gives you a totally different, unique number. Symmetric ciphers need a key and to populate, and random number generators are been used a lot. They're random enough, but in choosing your random number generators, there's probably some properties you want to think about. I want to make sure that there is the sequences, there's no correlation between the character sequences. You want to make sure they're long enough, and you want to make sure there's no uniformity in the pattern. So you want to double check that. Now, how can I make a key stronger? Is basically you lengthen it. Now, there's a couple of different ways to do that. One is a password key derivation function. There's standards set up to kind of do that. But it basically applies to the function of the password or the passphrase, along with, you'll see this word salt, and basically it's another added number that gets inserted into the algorithm that you don't know about. You got several different ways of trying to lengthen your password. Now, how do I know which of these I want to use? For most of our business stuff, any of them should work. We're really not protecting a lot of data. Now, one thing you got to worry about, if I'm doing a lot of data and speed's an issue, you want to make sure you take that into consideration. Or if it's highly sensitive and the data's got to be more secure than I care about speed, then you want to go with the more secure. The longer, it may take longer, but it's the most secure, harder to crack. And variable length keys are only important, it says, if you need them. So not necessarily that important unless you're based on how sensitive the material you are trying to detect. Now, another method, those are the symmetric key. Now, this is a public key encryption. Now, it's the opposite of a single key. You've got a 2-key process. One key is to encrypt the message. That's your public key. And another key is used to decrypt. That's your private key. You can freely, the public key, you can send it out any way you want. Send it an email, send it a text message. You don't care. But you want to make sure that you got to find a way to get that private key to the individual. So just keep that in mind. Now, granted, it's a little bit slower than some of the symmetric ciphers, but there are a few. Now, there's several different methods out there. There's the RSA, which is widely used, and then several others that have been looked at and investigated, and in some cases are used. But the question is, how do I identify good encryption? Well, I got to be very suspicious of encryption messages that say that, somebody says, hey, it's unbreakable, or, I've certified that this is a good. There is no certification on encryption. And you want to make sure if these people haven't spent their life, their careers developing this stuff, you don't want to mess with them. Now, we've all heard about digital signatures, and basically a digital signature, and we've used it. Maybe you've signed a mortgage or transferred information between you and your bank. Sometimes you'll use a digital signature. Sometimes you'll be asked to sign a document. But a digital signature is basically using asymmetric cryptography in reverse order. It isn't so much to encrypt the message, but it's to identify who sent the message. So usually some part of the message is encrypted or signed by the user's private key, and then it's decrypted using the public key. But it's a way of verifying who sent you the information. Now there's different digital certificates. A digital certificate is one contained by a trusted third party, usually called a certificate authority, that distributes that public key and provides a means to verify that key, is legit. There is a international standard, the X.509, that identifies the format and information contained in a digital certificate. There's a brief write-up in the text, but basically just know that this standard exists. So if you stay into security for any length of time. Okay. Certificate authorities, their primary role is to what? Digitally sign in public, the public key to a given user. So I want to make sure that I've identified, so I got to identify the person who's in it. I've got to issue the key. Now they may use a registration authority to handle the verification process of certificates being issued. Now, a public key infrastructure is a system that kind of binds public keys with a potential user, by means of a certificate authority. But it's just basically a network of trusted certificate authority servers. Now, you may have heard the thing is pretty good privacy. It's not just a definition of what good privacy is. It's a system. It's not a specific algorithm. It offers digital signatures, some asymmetric and symmetric encryptions, often used with email clients. It has its own, certificate format, but it's still a pretty good, because the only disadvantage to these are because it's only pretty good. The certificates are self-generated. I'm not using a certification, authority in trying to set this thing up. Now, anybody ever heard of a hashtag? Oh, yeah, we've all heard of hashtags. Well, hashing is a little different than a hashtag, but it takes a variable size bit of information and returns a fixed size string of data. Now, this returned value is also called a hash value. Hashing is basically a one-way. All I do is put the data in, I get this hashtag value out, and you can't unhash it to get back to your original source. Windows uses it to store your passwords. Now, you may hear the term salt, and basically salt, like I mentioned earlier, is just random bits that are used as one of the inputs into the hash. So just kind of, so basically you got to have the salt, and you have to have, the hash algorithm to kind of either try to break the code. So it just makes the things a little bit more complicated. A couple of, it just complicates, dictionary attacks or rainbow table attacks. And rainbow table attacks is just like certain groupings of data that people have used, that can use to compare information. Now, there's several different hash methods. The secure hash, it's definitely the most used. If you remember your Cisco days, you probably saw MD5 that was used. Now, MD5 has been determined that it's non-collision resistant, so you can sometimes get duplications in there. So you also have that RIPE-MD and the Havel method, but for the most part, secure hash algorithm is the one that's mostly used today. Now, you got to remember that if you're encrypting things, somebody's going to try to decrypt. There is no unbreakable encryption algorithm. So if I spend enough time, money, throw enough resources at it, eventually I can break just about any code. Of course, the trick is I want to make sure if it takes long enough, maybe if it takes years to break something, maybe by that time the data is no longer of value. So how long it takes to decrypt information determines how secure it is. Now, you've seen this, and probably even tried it yourself, to crack passwords. There are several applications out there. I think even some of the homework assignments you're going to get to, I think I assigned the ones with to try this. But administrators can use password crackings as to help test their systems. One of the well-known one is John the Ripper. Now that is a well-known cracking app, but it is used at your DOS prompt, a command line prompt. So it's a little more not user-friendly, but it kind of makes sure things limit probably who can use it. Rainbow tables is where you've created a series of tables that have certain code with certain input. So I've got certain data files that I know what the resulting algorithm will spit out. And I keep enough of those tables out that I can compare messages to try to, because what you want to try to do is, if I can break a little bit of the code, maybe I can jump between and make a determination as, okay, if the letter the word the is always indicated by 1, 2, 3, I can kind of go through and start saying, okay, where are all the 1, 2, 3s in the program, and try to piece that together, look at common letters and stuff. Well, Rainbow Tables says I'm going to create several of these tables that I know the outcome based on what sequence of data that there is, and from there I can then try to piece the puzzle together. So there's definitely some password crackers out there other than John the Ripper. And if you take a look at Moodle, I've got some links to some of these. So you got the Russian password crackers, passwordcrackers.com, elcomsoft.com. So there's several out there that you may want to try to play with. Now, John the Ripper, it's found in openwall.com. It's a free download. It works on the password files, not on live passwords. The password file is what each of your operating systems stores the passwords in, and each operating systems there are located at different locations. With Linux it's in the slash, etc, / password. Windows 95, it's in the .pwl file. And then in Windows 2000 and beyond, it's in the hidden file, the .sam file. So it would actually take these files and then try to get you an answer on that. It would try to crack those passwords. Now, basically there are, if I'm going to do some analyzing cryptology, cryptanalysis is just the science of trying to find alternative ways to break the cryptography. Usually not very successful, can be quite tedious, no guarantees of success. You've got brute force, frequency analysis. I'm looking how often does the word "the" appear. In World War II, some of the messages from Germany always had Heil Hitler at the end. So it would allow me to say, if Heil Hitler is this way, now I know what these letters mean. So now I can start backtracking into, other methods to try to decrypt the rest of the message. Some of them are known plain text. Okay, I know what I know what the code is for known, plain text. Or I know what the code is for certain chosen codes. Maybe I can do some kind of keys related to each other that I can kind of determine what the answer is. Or the birthday attack. How many people in a room before I can have the same birthday? So you start doing statistical analysis based on the number of people. How many samples do I have to come up with a probability that I can crack that code? There's a couple other differential cryptanalysis, linear cryptanalysis. Definitely a lot of, probably about as much going on in that science as there is any place else. Stenography. Now, stenography is the art of hiding things within a message. That way, when nobody, either the sender or unintended recipients, would look at either a picture or a message and would not see the message unless they know what they were looking for. So whether it's, taking a message, encrypting it, and hiding it in a photo or an audio file, it basically means, hey, there's nothing that's going to draw attention that there's a hidden message in there. Some of the key terms you want to keep in mind is the payload. That's the data that you're trying to covertly communicate. The carrier is a signal stream or data into where you're going to, in which the payload is hidden. The channel is what type of median. And then there's several tools out there that you can use to do that. Yeah, so you can go look up one of those and play some games with it. Now, steg analysis is basically detecting hidden messages, and there's some ways of doing it. Raw quick pair method basically says, what am I doing? I'm just comparing the message with pixels in a photo, and says what's different about them. Sometimes I'll use statistics and the chi-square analysis and try to determine if there's a change. If I'm doing in audio messages, I'm looking for noise distortion. Has somebody inserted something in there that it doesn't belong? So there's several different methods there. But now the latest method is quantum computing. I've posted a couple of links as to more information on quantum computing, or at least what it is. But it basically allows, right now you're used to computers, it's 1 zeros, it's binary. Well, quantum computing allows for more than just 0 and 1. So in quantum-based algorithms are superior factoring. So all of the RSA algorithms, they would just become obsolete because they were based on large prime numbers. And if it's very easy to with the power and this quantum computing would make a lot of what we do today as far as security become obsolete. So in this chapter in encryption, we've covered a lot of material. One, just remember, it had a very simple beginning. Those beginnings from switching letters to become more mathematical, becomes the modern methods are very complex. We can be symmetrical or asymmetrical, whether it's a single key or a public or private key. Some of the symmetric ideas, you've got DES and AES are probably the ones that are used the most. Asymmetric, RSA is probably the one that the public can probably remember, that no encryption is unbreakable. Digital signatures, basically asymmetric cryptography in reverse order, but they're just to identify the user, validate the users. There are certificate authorities that provide trusted verification of those certificates. If you don't need a third party, you can use the pretty good protocol. They don't use certificate authorities. Now, hashing is basically returns a variable size input to a fixed size output. MD5 or SHA are the more common, but MD5 does have some weaknesses. Not enough to ban it from being used, but just people need to be aware that there are weaknesses in there. And more people are sliding to the SHA. Decryption is difficult, and usually not successful, but there are methods out there. Passwords can be cracked with tools like John the Ripper or rainbow tables. Cryptanalysis, attempts to break cryptography. There are several different ways, from brute force to differential and linear cryptanalysis. And stenography is the art or science of placing messages, encrypted messages, in hidden files, pretty much in plain sight, but whether it's audio or video. So hopefully this gives you a summary, or maybe a little bit more information than you had from Security 110. Hopefully it helps. Talk to you later. Bye-bye.